Welcome to my second video on modding the Creality Ender 5 S1. In the last episode I installed a bunch of silent fans, which quiets the printer down greatly. But in this episode I'm going to be focusing on speed. I've got a need for speed, some might say. So I'm going to be installing this Creality Sonic pad, and I'm also going to install this Volcano CHT nozzle. In my last video, I briefly pointed out that the Ender 5 has this kind of half volcano-sized nozzle. You can see it kind of slots in here right in between the standard-sized nozzle and a volcano nozzle. So I'm calling it a half volcano nozzle. Maybe we can call it a demi-volcano nozzle. I would really like to upgrade this thing to a Volcano CHT nozzle because that's going to offer me the best print speeds. You can see it's got that 3-lobed inlet geometry, and I should be able to push insane print volumes with this. And taking a little inspiration from a CNC kitchen video, I'm going to be using D's brass nuts in order to make up the gap between this demi-volcano nozzle and the full volcano nozzle. So essentially I want to add spacers until the threaded portion of these two nozzle systems is exactly the same. Adding 2 of these nuts makes approximately the same threaded length, but the demi-volcano is just a little bit longer. So if I want to be accurate about this, I need to sand one of these nuts down. CNC Kitchen has a little lathe that he uses on small projects like this. I'm going to use a poor man's lathe, aka a DeWalt cordless drill, and just tighten this nozzle into the jaws. So I'm going to just put these nuts on some sandpaper. My favorite surface for sanding things are these bulletproof steel plates. They're nice and flat, and if you get some adhesive-backed sandpaper, you can stick some on here and it works great. And I know you want to ask why I have a bunch of bulletproof steel plates. Anyways, I'm going to keep sanding away at these nuts so that they're a little bit slimmer and they'll fit into the volcano nozzle installation. Alright, now these nuts are just thin enough that it equalizes the length of the threaded portion of these two nozzles. And as a happy little accident, now when these nuts are tightened up against each other, they just happen to be perfectly flush, which is a really nice touch. Now that I've got that out of the way, I'm going to break out a kilo of the good stuff. Well, that's a little disappointing, but I guess this is pretty cool too. This is the Biku H2 extruder. I was hoping I could get some of the good stuff in powdered form, but instead I'm going to have to use it in syringe form. That's right, I got some boron nitride paste here. So it's time to install this Volcano CHT nozzle. I always use my Knipex wrench pliers to make sure I'm securely holding on to the heater block when I'm fastening and unfastening nozzles. It's really great because its parallel flat jaws are non-marring, and it lets me get a tight grip on any sized object. Now it's time to apply some boron nitride paste. Then I'll tighten this with one click, making sure to securely hold the heater block. And then I'll tighten down these nuts. And I'm going to clean up afterwards using a little towelette. So we're looking pretty good there. We got our new high flow nozzle installed. Now it's time to get this thing moving a little faster using the Creality Sonic pad. The term pad isn't like universally cool, but you know what? It's like a sonic boom / iPad thing. So we're going to install it and see if we can make this thing go any faster. Doing a brief little unboxing, we've got the Sonic pad here. Then we've got a little power adapter. Looks like it provides 12 volts at 3 amps, so 36 watts. That's quite a bit of power. I guess it is powering a little mini computer. Then we've got this little accelerometer, which is going to be used for input shaping. Some SD cards and adapters, and our USB cable. It's got little legs that fold out. That's kind of cool. This is something that I saw in the initial announcement video that I thought was kind of strange. So you gotta plug in one of these little USB-C adapters onto this, and then plug all of that in to the printer. So it's just kind of sticking off to the side here. That's just asking to get broken. That's just so bad. They need to find a way to tuck this away, or plugging it into the inside of the machine. I would prefer that. We're asking for trouble here. Come on, Creality. Anyways, so it looks like I've got this extra cable and this USB cable. Kind of a messy install, but if it delivers the performance that I'm after, I guess I can forgive it. But you can see these two cables are making my workspace extremely messy looking. If these two cables weren't here, my desk would be a lot cleaner. So to finish up this volcano transformation, I'm also going to need to move this CR Touch down about 8 millimeters, because two of these nuts stacked together is about 8 millimeters. So I just need to unscrew this CR Touch, and here's the old screws that I just took out, and here's the new screw with a spacer that's going to go behind the CR Touch, just to drop it down a little bit further. So we'll pull that CR Touch down a little bit, insert a spacer above the CR Touch, and just in case it's not apparent in this video, this is not the easiest thing to do. I got the spacers out of this kit. It comes with all these little Delrin spacers or nylon spacers. You end up using a lot of M3 hardware when you're dealing with 3D printers, so having extra M3 fasteners and spacers and all sorts of stuff is always handy. Do yourself a favor and just buy a giant pack of these M3 fasteners, because they're going to come in handy if you like modding 3D printers. Unfortunately, the CR Touch touches the build plate before the nozzle does, so that means I've got to move the CR Touch up a little bit, so I've basically got to install thinner spacers. I'm going to use the 6mm long spacers instead. Having an all black assembly like this looks cool, but one big issue with electronics assembly is you want to be able to see what the hell you're doing, and when everything's black it absorbs any available light in there, so you really can't see what you're doing very easily. If you look at clean rooms, usually everything's all white because that allows the best visibility, but it seems like a lot of these companies like that cool black aesthetic. So you end up not being able to see what the heck you're doing. So yeah, if you're designing a 3D printer, I think you'd really be doing yourself a favor by making everything white instead of making everything black. Alright, well there we go. That's all installed now. Seems to be on there pretty good. So we'll leave it at that. The next thing I've got to do is actually set up this sonic pad, so I'm going to try and turn it on here. Looks pretty good. Nice bright display, very crisp and clear text. Ooh, and look at that. We got a nice little logo animation thing going on. Okay, why does the bar load more than once? I think Creality doesn't understand the function of a progress bar. It's supposed to indicate how much progress you've made towards opening the application, but I guess they just kind of view it as an animation to keep going. Okay, English. Ooh, it's got a nice speaker too. This is fun. Antarctica. Wow. Just in case you live in Antarctica, you've got your region select there. Alright. I don't know what any of these places are. I'm just going to pick New York. Alright, Creality, you need to simplify this a little bit. We don't need 10 regions of Antarctica and 100 regions in America. Just like kind of boil it down a little bit for our benefit. Okay, now I can download the latest version of firmware for the Sonic Pad. I'm going to go ahead and do that. Added 11 models of one-touch changeover. So Ender 5S1. There we go. That's what we need. Let's let that finish, and then we'll be able to flash our Ender 5S1 over to Klipper. Now it looks like the Ender 5 series is popping up. You just have to update the firmware so it loads all of those new printer profiles on there. So I'm going to scroll over to the Ender 5S1 right there. Next step. So it says to insert the card reader. So I guess that's this thing. And plug it into the side. Flash the firmware. Woo. So it's been written to the memory card. Please insert it into the printer. So I'll go ahead and unplug this and plug it into my Ender 5S1 over here and turn the printer on. So it should be flashing that firmware onto this printer as we speak. At this point, the LCD screen, this little touch screen, is completely useless now. It'd be nice if they displayed a little bit of information here. I guess you just want to completely replace the screen with this thing, which isn't necessarily a bad thing. And then it says, please connect the printer to the screen using USB port 1. Connected successfully. So next step, firmware has been flashed successfully. Please click on the next step for self-test. Hot end fan is starting up. Please check if the fan is spinning properly. Doesn't look like it's spinning properly. Come on. Spin. Well, it's not spinning properly. It's not telling me what to do if it's not spinning properly. Oh, I've got the Ender 3S1 on here. Let's go back. Ender 5. Ender 5S1. Next step. So we'll go through this again. Hot end fan is starting up. Please check if the fan is spinning properly. Hello? Are you there? Yeah, that's kind of concerning. Why isn't the hot end fan spinning? Alright, so I spent a while kind of messing with this printer and getting it to work. Basically, the hot end fan wasn't working, and I know you're going to blame me for doing a shit job at installing this thing, but no, it was Creality's fault. The config file that they sent with this printer was all wrong. So basically, I had to figure out what was going on here. This is where it sets up the definition of the hot end printer. That's like that hot end heatsink fan. I just commented this all out and replaced it with this code, which I stole from the Ender 3S1. Hopefully this will be fixed in future editions of the code that Creality is releasing, but for now, that's something that I had to fix myself. Alright, well, let's get this thing going. I mean, now that we've got Klipper, I want to do some input shaping and get this thing like cooking at super fast print speeds. So let's do this. This is going to be really exciting. One thing that I want to do before I get going here is I want to take this whole thing and just set it on the ground, because this table is a little bit wobbly, and that's going to affect my print speeds because I'm going to have some resonance with the table and it'll totally mess with the input shaping. So let me just put it on a solid surface, which will be the ground here. Now that I've got everything all set up, I can just go to this IP address. So I have it saved in my my tabs up here. So just click this one and it opens up this nice interface. So everything's all right here. I can change all sorts of settings on the printer. I can run commands through this little console. There's just lots of great stuff about using a machine on Klipper. One of the best things is actually you can plug in a webcam and you'll get a webcam feed in this web interface. That way you can check on your prints from anywhere in your house, which is a huge advantage. There's one USB port named CAM, so you'll want to plug into the CAM port. Oh, here we go. There's the webcam feed. You can see it right there. It seems like no matter what I do, I can't increase this acceleration speed using Prusa Slicer. I've looked at every acceleration setting. The only thing I can imagine limiting me right now is this one, maximum acceleration while extruding. I guess I'll turn that up too. One thing I don't really like about the Sonic Pad is it always turns to this black screen. So you have to touch it to wake it up. It'd be nice if it had some kind of always-on display. Anyways, I switched this back over to a matte green-gray filament, just so that we get something that's a little more consistent for our print quality analysis. Alright, this is much better. So it turns out that max acceleration while extruding setting was what I needed to change. Now you can see everything's moving a lot faster. We should be locked in at that 5,000 millimeters per second squared acceleration rate from now on. And this is what you really want to get fast print speeds. Just setting your print speed to be high doesn't really do much. You also need fast accelerations, because most of the travel moves and print moves when you're printing are actually pretty small. So if you're just printing a short segment, then you're never going to get up to that maximum speed that you specify unless you also have a high acceleration rate. So now when I look at my flow rates in Klipper, we're peaking around 22 millimeters cubed per second, which is pretty good. Now this is being achieved with a combination of over-extrusion, which is where I basically extrude to the size of a 0.6 millimeter nozzle despite using a 0.4 millimeter nozzle. So it's just putting extra plastic out there, which is kind of helping bolster my print speed. Alright, looks like I'm coming up with a 15-minute benchy. It's not looking the best quality, but for functional parts I think this kind of speed will work just fine. I mean, honestly, it's kind of hideous, but we're going for speed here. Alright, not bad. That was a 15-minute, 46-second benchy. So not bad at all in terms of speed. Looks like the quality could use some work. I think the biggest issue here is insufficient part cooling. So in my next episode I'm going to be tackling that, and I'll be developing a nice fan duct for this printer. This last benchy will be more of a print quality test. So this is printing with 2000 millimeters per second squared accelerations. I'll leave the speed at 200%. We'll keep this thing moving relatively fast. We'll just have the accelerations turned down a little bit so that it slows things down a little bit and we won't have so much ringing or any issues like that. So let's see how this goes. Alright, so we're going to wrap things up here by doing a print quality analysis, looking at these various prints that were done at different speeds with different slicer settings. And then I'm going to go over my final thoughts on the pros and cons of this Sonic Pad setup. I've arranged these in order of slowest to fastest, and this is the highest quality one. This one printed in 50 minutes, actually 49 minutes and 40 seconds. So I'm getting these times directly off of the Sonic Pad. The nice thing about Klipper is that it saves all of the print times of your previous prints, so you know exactly how long each print took. Anyways, this one, the highest quality benchy, was printed in 49 minutes and 40 seconds. And this is a really, really nice print. The only defect I can see is the bow there. It's got a little bit of issues with insufficient part cooling, but I suspect that has more to do with my part cooling setup. Since I installed that Volcano nozzle, it's actually down a little bit lower than where the fans are blowing. So that 2000 meters per second squared acceleration rate produced really good print quality at pretty fast speeds. I then increased the accelerations to 5,000 and then 10,000 on this print. So this one was printing really fast. If I look at the actual time to complete this one printed in 41 minutes. This is only a 10-minute difference between these two. So 41 minutes versus 50 minutes. I would just stick with the slightly slower speed and get this great quality rather than bump up the speed to levels where it degrades the print quality slightly. Then we have these other two benchies, and these were printed using some different slicer settings. Basically, I set the slicer up to treat this 0.4 millimeter nozzle as if it was a 0.6 millimeter nozzle. Instead of laying down a bead of filament that's 0.4 millimeters wide, this was laying down a bead that was 0.6 millimeters wide with a layer thickness of 0.4 millimeters. So that's a pretty substantial bead of filament that it was laying down. And this first one was printed with accelerations around 500 millimeters per second squared. And that benchy took 38 minutes to complete. So it was faster than either of these two benchies. But you can see it's not as good at recreating fine details. And any of these sloped surfaces, they have a lot of rasterization from the thick layer lines. Then we go to this one, which was the absolute fastest print quality. And aside from the part cooling issues, it doesn't look a whole lot different than this one. Clearly it had some issues with prints not solidifying all the way. You can see that bridging up at the roof of the benchy is just like drooping down. Just kind of looks like it was melted. But it printed really fast, and this one was printed with 5,000 millimeters per second acceleration, and it actually completed in 17 minutes 39 seconds. So this was the fastest benchy we got, and I think I could actually get this to come out with this level of quality if I just increase the part cooling. So I'm going to design a new fan duct, probably dual 50-15 fans, since that seems to be the most popular configuration people like to do. And for good reason. It provides an excellent amount of part cooling. Something kind of funny here is the benchy's door, instead of having a nice rounded shape like this, like an arch, it just looks square. So that plastic got displaced. But yeah, this benchy is definitely not very good quality. One of the things I wanted to accomplish with this printer was to have a printer that can do really nice quality prints like this, but also be able to crank up the print speeds to making stuff like this, maybe for like more functional parts where I just need a plate with a couple holes in it, and be able to just crank out parts really quickly, or slow down and do detailed prints like this. And I think this setup succeeds in doing that. For a similar quality benchy as this one, I think most of my other printers would take about an hour and a half to 2 hours to do this. So it's faster for nice detailed prints, but it's also able to be turned up to very high speeds and get usable results as well. So this is a printer that I'm going to be playing with and tuning and upgrading a little bit more until I get it to a place where I'm really happy with it. But this is what I'm working with so far. Not the best quality, but in 17 minutes, that's pretty impressive. Now let's talk about this sonic pad. There's a couple things that I don't like about it. One is that the display turns off. I wish there was a way to just keep it on all the time. Maybe there is a setting here. Okay, so break screen, I can just set that to never, so it'll just stay on. When I'm coming down to check on my printers, I want to be able to just glance at something and see what's going on. If I have to come over here, walk up to the screen, touch it to enable it, and then take a look, that's just extra steps and it's kind of annoying. But the brightness and the contrast of this display and the size of it are all really good. These are things that I think Creality has done a good job with, and when I'm rebooting the printer, like if I make some changes and the printer needs to restart, it restarts really quickly. That was something that was kind of odd about the Biku Huracan that I was reviewing earlier, is that when you restarted the printer and had to reboot the Klipper stuff, it would take like 45 seconds to turn on. My least favorite thing about this screen is that it's kind of locked down and you can't program it to do things that Creality doesn't want you to do. For instance, I would really like to be able to just flash my own version of Linux onto this machine, and then I could like SSH into there and change all sorts of settings, but this is kind of a locked down display. The other issue that I'm seeing already is there's some scratches that are showing up on the screen. So you can see just from my 1 day of usage, there's some scratches starting to appear. I don't know if it's showing up super well, but there's the scratches. Like I've just been, touching and using this thing, and for scratches to be showing up like that already means that there's something going on here. I think they're using kind of a softer plastic for this display. It's not a glass screen like you get on like your smartphones and stuff. So I think it would be wise to put some kind of screen protector over this if you're planning on using this for a long period of time. In terms of the speed and responsiveness of this device, I think it works really well, and the setup process was really simple. I think that's probably the biggest selling point to this thing. I just plugged in this SD card following their instructions, and it put the correct version of firmware that I needed to install onto my Ender 5, and then I just plugged it into the Ender 5 S1, turned it on, and it was working. Aside from that one little bug with the fan not working, that was a little annoying. Another thing that's a little odd about this machine is if I go into the configuration here and I want to record time lapses, I have to set this up using the sonic pad. If I change these settings on the web interface for Klipper, which is how you would do it on most other machines, it doesn't accept those changes. You have to go in here and turn on the camera through this interface, and then you can get it working. One nice thing about using this sonic pad is the printer now homes at the top of the print area, so it doesn't have to go all the way down to the bottom and then pick all the way back up to the top. I spent a lot of time waiting for this thing to do that when I was doing my initial review for the Ender 5 S1. If you look at this mesh, there's something wrong with the bed. I was running a large flat print like this, and there's some issues cropping up. This is just the first layer, and I stopped the print. I did the bed leveling procedure, and the mesh was loaded, so everything should have printed perfectly flat, and I should have got like a really nice first layer. A perfect first layer, one might say. But if we look over here, this is far from a perfect first layer. There's an issue down here where the nozzle wasn't close enough to the bed, so there's clearly an issue there. You can see the gaps between each line. And then towards the middle, it ends up being really nice. So here, this is like exactly what you want to see. Everything's perfectly laid down. There's no gaps, there's no over extrusion. But if we get to the right side, here you can see there's like too much plastic being laid down. so you end up getting these ripply patterns, and that's from the bed level not being perfect. It might have something to do with the way the mesh is stored and used in the Sonic pad, but I tried a bunch of different things to get this to work. In the end, the only thing that would probably work is if I ran the automatic bed leveling, stored that mesh, and then tightened down the screws on the right side to pull this edge down and loosen the screws on the left side to bring this one up, just to do like a manual bed leveling to account for the automatic bed leveling not loading correctly. So there's something going on there. It might be an issue in the code in the Sonic pad or in the version of Klipper that they're working on. But this was happening on all of my prints. With the benchies and other smaller objects, it wasn't that big of a deal because you're just printing in the center where the bed level works pretty well. But towards the edges here, I was getting all sorts of issues and it was just kind of looking ugly. One thing that you can do to get around the first layer issues if your bed isn't perfectly flat is to just lay down really thick layers of plastic. So with this print, it's a mini snowman mold, so I don't have to roll the individual balls, I can just stamp them out. But to get this to stick to the bed, I just used really thick layers. I was printing with my extra thick profile, which basically treats the 0.4mm nozzle as if it's a 0.6mm nozzle, and it lays down a bunch of extra plastic which just kind of smushes into the first layer, and that extra plastic just kind of fills the gap and gives you a decent first layer. It's not as good as having a perfectly tuned printer because this forces you to use really thick layer lines, and also it doesn't have as good or as consistent of bed adhesion, but it gets the job done. And if you just need to get a large print printed and you don't mind using a thick first layer, then this will work just fine. So I'm planning on using this. If I get any snow, I'll be able to crank out like 100 little snowmen. So if someone walks around the corner in a dark alley and they see 100 of these little snowmen standing there, might be able to creep some people out. So that'll be fun. But you gotta have working mesh bed leveling on a printer like this, especially since the bed itself is pretty warped. So there's some work to do. This isn't a perfect printer yet. So one of the things that I really like about this printer is how moddable it is. Like I've been able to just add all these extra things onto it, but it's definitely a fun project. This modder board has been working out pretty well for me. I've got my thermistor rewired to be plugged in up here, and I've got my built-in resistor, which is helping me run this 12-volt Noctua fan. Super quiet. Seems like there's a couple bugs that need to be worked out, but overall this is a pretty good platform. I think Creality have done a decent job of porting Klipper into their ecosystem of printers. At the end of the day, I think it needs a little work, but if you just want to make your printer go fast and you've already got a Creality machine, then getting one of these Sonic pads is really not that bad of an investment because you're getting all sorts of new features. You get the web interface, you get the automatic webcam recording. I do think the Sonic pad is a great investment if you've already got an Ender 3 or an Ender 5 that you want to throw Klipper onto and you don't want to spend the time setting up all these different things. With the Sonic pad, you just get it, you plug in the SD card, follow the step-by-step instructions, and then boom, you've got Klipper running on your printer. But overall, it does what it promises to do, which is to bring Klipper and those higher print speeds to your Creality machines with a relatively low barrier to entry in terms of technical knowledge. You don't have to learn how to program computers or do any of this crazy stuff to get it working. You just buy the thing, follow the step-by-step instructions, and then you can get it set up on your Creality printer. Alright, well thanks for watching this episode of Nathan Builds Robots. It's been fun. Stay tuned for the next upgrades I'll be putting onto this machine. I definitely want to increase the part cooling and get printing at even higher speeds, so stay tuned for that. Alright, thanks for watching, and I'll see you in the next episode.